and welcome to the first of the GeoTalks Express series for 2021. It's been a while since we've done one of these, since before the holiday period. Glad to be back. It's great to be back, and a great subject we're going to be dealing with today. We're going to be talking about bathymetric analysis in Global Mapper. As you can see on the screen, we're going to be taking a plunge underneath the waves, dealing with a lot of the same tools that we would cover in our terrain analysis presentations, but from a bathymetric perspective. For this presentation, for this hour, I'm joined by Billy Noble. Billy's one of our tech crew. Good morning, Billy.
Good morning, David. How are you?
Great. Are you ready to take a plunge into the ocean?
Oh, I'm ready. I got my scuba diving gear on.
Excellent. Glad to hear it. Glad to hear it. Before we get started with our presentation, a few housekeeping issues to deal with. Just for those of you who have not attended one of our presentations before, you are in listen-only mode. Obviously, hopefully, you're hearing myself and you're hearing Billy, but we can't hear you. I know a lot of you have questions. A lot of you, when you attend these presentations, have questions you want to ask. And if that's the case, please feel free to use that questions panel that you will find over on the right-hand side of your screen. We will try during the presentation to answer some of those questions, either verbally, if time permits, or in writing. Now, if we don't get to your question specifically, and I know there's a lot of folks in this presentation today, and if we don't get to answer your question specifically, we will follow up with you. We have a record of who has asked the questions, and we will send you an email with a direct response to any questions you might have. And we will also post a blog with all of the questions and answers. That will happen in the next few days. This session is being recorded, so if you have to step away or you want to revisit some of the themes we're dealing with today, or indeed, obviously, if you're watching the recording, welcome to the recording. But this will be posted on our YouTube channel within a few days, and feel free to share it with your colleagues. It will be available for general viewing. So. We have a number of additional sessions coming up within the next few weeks. We are in the midst of a release process. Those of you who keep track of what's going on in Blue Marble Geographics may be aware that right now, today, we are scheduled to release a new version of Global Mapper. Version 22.1 is scheduled for release, and we're going to have a webinar that covers the new functionality in that release. The release is today, by the way. If you want to grab the latest version, please, by all means, at the end of today, it should be available. You can go to our website and you can download a trial version. But if you want to find out a little bit more about what's in this new release, join us on March 3rd for our hour-long presentation on what's new. We'll follow up after about a week later, March 10th, with a specific presentation on the LiDAR module functionality that's been added in this release as well. So 2 what's new webinars coming up within the next few weeks. We're going to follow that, kind of changing our focus a little bit and look at some coordinate system management. We're going to take a look at Global Mapper, but also Geographic Calculator. Those of you interested specifically in 3D coordinate systems, and indeed many of you are here today, I'm sure this is going to be a relevant topic. Join us on March 17th, St. Patrick's Day, and we'll cover working with Global Mapper and Geographic Calculator in conjunction with each other to talk about 3D coordinate systems. If you need more information on any of these webinars or you want to register, the URL is right here on your screen. Also, we have some training coming up. Next week, we have our first public training class of 2021, 22nd, 26th. That's a morning session, 3 hours each morning. If you want some training on Global Mapper, there's still space in that class. Following week, we're going to do a training class on the LiDAR module. That's a 3-day class, 2.5 hours per day training on the LiDAR module. Once again, more information on that and additional training sessions that are coming up. You can see the URL on your screen. Feel free to sign up for those classes, again, to give you more information on the use of Global Mapper. So back to today, what are we going to be covering? What is our agenda for today? Now, this is in no particular order. We're going to start by addressing the question, what exactly is bathymetry? I know a lot of folks attend these presentations regardless of the topic, and maybe some of you who have been using Global Mapper in another context may not be familiar with what bathymetry is. So we're going to begin at a high level explaining exactly what we're talking about here, what we're going to be dealing with in this presentation. As with many of our workflows, a good place to start is where to find data. And we've got a couple of sources of data that we're going to take a look at online. We're going to be dealing with some file formats, and notice some questions coming in already about some of the specific file types. We'll be looking at some specific types of files. We'll also be looking at some online sources as well. So essentially answering the question, where do I exactly get my bathymetric data? Once we have some data in the application, we're going to take a look at some of the visualization options. Now, those of you who have used Global Mapper for terrain analysis, a lot of these will be similar, except obviously we're dealing with everything in an inverse perspective. We're dealing with everything under under sea level. But we'll introduce some of those visualize options, things like shaders, 3D viewing, profiling, etc., from a bathymetric perspective. We're then going to take a look at the generation of a bathymetric model or a bathymetric terrain layer, DTM if you like, from a point cloud. In fact, the screenshot you see on my screen right now is a sample of some of the data we'll be looking at. It's similar in structure to LiDAR. Those of you who have used LiDAR data, except obviously it's not LiDAR derived. We're going to take a look at where this data came from, and we're going to generate a surface from this. And actually, we're going to conduct a few analysis procedures using that sample data. Again, you're seeing that over on the left side of my screen. We'll generate some contours. That's a common use case when dealing with terrain data of any time with dealing with 3D data. In fact, it's interesting that contours were first used for bathymetric analysis. They were later applied to terrestrial applications, but they began their existence as a bathymetric visualization tool. So we'll generate some contours. We'll also get into some of the analysis functions in Global Mapper that allow us to modify a surface, modify in this case the seabed. Perhaps maybe we want to simulate the process of dredging a channel, and we'll take a look at how we can visualize that, essentially cutting a section out of our model. We'll calculate some volumes, we'll generate a modified surface, and we'll deal with some other visualization tools related to that specific function. So this is, again, no particular order. We'll be dealing with all of these themes, hopefully, as we go through. Myself and Billy will be looking at some specific workflows addressing these bullets. So the first bullet there was, what is bathymetry? What are we talking about here? For those of you who don't know, it's quite simply, well, originally it was the term that was used to refer to the depth of the ocean. Now, today it's been more generally applied to describe the seafloor structure or lake bed, or indeed any surface that's underneath the water. Bathymetric analysis basically takes everything below the water level. Similar to terrain analysis or topographic analysis from a terrestrial perspective, we're going to be looking at what's underneath the waves. Seafloor geomorphological data is typically collected using sonar. Now, there's other technologies as well, especially near shore. You can generate data using LiDAR. Obviously, light penetration is key and clarity of the water, but most of the data that you're going to find will be sonar, similar in terms of the underlying technology to LiDAR, but using sound waves, obviously. We're going to be looking at some examples of sonar data, or bringing some sonar data into Global Mapper. You can also derive bathymetric data from satellite measurements. Now, one of the first data sets we're going to take a look at was generated through this procedure. Analysis of the sea surface level is a reflection on what's underneath. And this is based on anomalies in the gravitational pull of different features. So basically, where the sea level bulges, it's an indication of some sort of seamount or something of that type. And we're going to see the results of that in one of our first examples, in one of our first scenarios. So multiple ways of generating or accessing bathymetric data. And let's take a look at a few of those before we delve into Global Mapper itself. I'm actually going to bring up a couple of websites here. For those of you who want to get started with this, we'll take a look at some data sources. Now, the first one I'm going to bring up here, it's a website. I'm going to drag it in from off screen. This is a website that provides access to the general bathymetric chart of the oceans. Those of you who are not familiar with this, it's a collaborative effort, multiple agencies contributing to a data set that's accessible to all, providing bathymetric data worldwide. Now, this was launched in conjunction with the United Nations Ocean Conference in 2017, and its aim is to produce a definitive map of the ocean floor by 2030. Now, that's not too far off in the distance, but the idea here is to collect data from multiple sources around the world, providing access to that data. I'm going to zoom in a little closer here just to give us a look at what we're seeing here. you can see landforms here. You can see quite clearly the continental shelf along the edge of the North American continent here. And it's the data is not high resolution. It's not going to give you localized information, but certainly from a regional perspective, it's a phenomenal data source, freely available. And you'll note here with the instructions right below, we can access this data in real time. I'm going to simulate the process of selecting an area. I can download this in one of the available formats here, all of which, by the way, are supported in Global Mapper. So we could download a GeoTIFF, for instance. If you're interested, you can simply add this to your basket and grab this data. Now, we're going to be taking a look at some of this data in Global Mapper in just a few minutes, but this is a great source of bathymetric data. You can access it right from this website, download.gebco.net. Again, general bathymetric chart of the ocean. Another source of data, more localized data, and again, I'm going to bring up a website here, hosted by NOAA. This is data that's hosted by the National Centers for Environmental Information. And you'll see on the screen, again, an interactive viewer here showing what data sets are available. And again, I'm going to zoom in a little closer here. Hopefully you're seeing my zoomed view here, zooming into kind of the eastern seaboard of the US. It's a little bit confusing what we're looking at here. You're looking at line features, also looking at area features. But the line features are multi-beam survey track lines. These indicate areas where multi-beam sonar surveys have been conducted. You can actually look at the footprints as well to show the geographic extent of what's included. Also, there's hydrographic data, hydrographic surveys, a little bit older data as well. And again, this data is accessible. If you select one of these areas, you can see what data is available. I'm just going to click on an area right off the coast of Maine here, close to where I'm sitting right now. Again, hopefully you're seeing my zoomed view coming in here. And if I tap on one of these areas, you can see the data is available. I can download it directly. And again, we're going to be looking at some of these data sets specifically in Global Mapper as well. So another source of data, as noted here, online data, you can access bathymetric data. Let's take a look at Global Mapper itself to show another way to get bathymetric data. Now, those of you who have not used Global Mapper before, Global Mapper, one of the defining characteristics of the application is its file format support. Global Mapper supports over 300 formats of data, and we're going to be taking a look at some of those formats in just a minute. But it also provides access to online data. And you can access that directly either from the toolbar or even right here in the middle of my introductory screen. Click the Online Sources button, and you'll see a list of available data sources. I'm going to click very specifically on the worldwide data category here, and you'll notice a couple of options here. First of all, you'll notice the Global Bathymetric Chart of the Ocean is a streamable data set. You can actually stream it right into Global Mapper. I should stress that this is not a gridded data set. It's not a terrain layer. It's a raster visualization, basically a shaded relief model. I'm going to take a look at this in just a second in the application. A few other options in here. We've got the NOAA Ocean Base Map, and we've also got the OpenStreetMap as a stream service. Now, or sorry, OpenSeaMap, I'm sorry. OpenSeaMap is a partner project of the OpenStreetMap project. Many of you, I'm sure, are familiar with OpenStreetMap. OpenSeaMap provides access to bathymetric data using the same mechanism. And again, this is a publicly available data set. You can contribute to this just like you can OpenStreetMap. So if you do spend some time out in the ocean and you want to help develop this free service, OpenSeaMap is a platform that will allow that data to be distributed. So just some online sources. I'm going to take a look very quickly at one of those specifically. This is I brought it in ahead of time because streaming takes a little bit of time. This is the general bathymetric chart of the ocean at a high level, as you can see here. And I've actually projected this display with an orthographic projection. This is data that's available free of charge, streamable within Global Mapper. A more close-up perspective, I'll just zoom in here to the Puerto Rico Trench you can see, and you can see that level of detail. I should stress again, this is simply an image. This data in its streamed form is not available for 3D analysis. However, the data that we're seeing here, the data we're displaying, is available. And I'm actually going to take a look at some of that data and do some analysis of this data, again, at a very high level. It's not very high resolution, but we'll take a look at some of this in its gridded form in just a second. We can, again, download it from the website I showed you previously. So just some examples of where you can get bathymetric data. I mentioned
Okay.
that Global Mapper supports over 300 file formats. Included in those are some specific bathymetric formats. And Billy, I'm going to hand over to you, and maybe you could show us a couple of examples of the types of files that could be imported into Global Mapper.
Sure thing, David. You see my screen?
Absolutely, yes, I do.
Yeah, I have a great transition here, seamless. Kind of like these charts I'm going to show you in just a sec. So I'm going to go ahead and show you how to load these BSP navigational charts into Global Mapper as a viewer or something you can use out in the field or out in the ocean, more specifically. So take a look at this file directory. You see I have the BSP files with the .kap files, and the .kap files are the ones you'll actually want to load in Global Mapper. So I'm using my keyboard shortcuts along with my mouse. I will click Control and click both of these and just drag them right into Global Mapper. So you see that these are two raster images along the coast of Maine. And you can see that they are a little bit overlapping here. And these are similar if you've seen previous videos or webinars where we looked at USGS quads. You can actually crop these collars to the edge of these maps. So if we go back here to the control center, they're both loaded here in the control center on the left side. I can go to the right click and go to options. And right here in the raster options tabs, in the cropping tab, you can see we have various different options here to crop these rasters. But there's already here one called automatically crop collar. And you can see right in this option, you see BSP right here. So I click apply. You can see that this file on the bottom, that the raster collar had been cropped. So if I do go ahead and go to the second one, I can do the same thing as well. And now you have a seamless BSP chart in your workspace that's now blended well together. And someone had mentioned if you were able to export multiple of these into one. And so now that I have done this, you can use the file export option if you want to export the raster image format, and just won't actually do this, but you can go to BSP marine chart. And you can also do this from the control center as well. So if you had these in a group, I'm a little off script here, David, but then if you wanted to do the same thing here, you could go to the layer menu and go to export, and then choose the BSP option from the same drop down menu as well. So
yeah, and Billy, we have a few questions coming in. You obviously have stoked some interest here. Someone's asking specifically if these can be merged with topo maps. Now, I assume topo maps we're talking about terrain data, and the answer to that is yes. If you want to visualize these superimposed on top of a bathymetric model, it's not something we prepped for this presentation, but absolutely you can do that. So, for instance, if you want to download that bathymetric data from that website, you can actually have that as a underlying surface layer and then render these as 3D. So yes, the answer to that question is yes, you can absolutely do that.
Yep. And as I noted a little bit in my introduction, you can take these files out of the field if you have Global Mapper on a vessel. You can have these on your boat, and if you have a plugged in GPS, you can actually locate where you are on the chart in the ocean where you are if you have the GPS capability. So that's also a very handy thing. And as well as using these charts, if you export these to a Global Mapper mobile package in the menu here. So if you have it on your tablet or phone out on a vessel as well, you can also stay on track or see where you are out in the ocean with these BSP charts right on Global Mapper mobile. Okay, any more questions on this?
Quick question came in. This is a simple one. I'll just answer it verbally. Someone's asking if we can reproject. Yes. If you need to reproject any map layer or any view in Global Mapper, you can define the projection. Just go to configuration, whatever the on-screen projection is, and you can define that from, again, configuration. That will then be inherited by any files you export. So as Billy simulated there, we could export this merged group, if you like, of BSB charts into a single file, and it could be in whatever projection you define.
Okay, great. So now I'm going to take a look at going from raster now to a vector format. Another popular option are ENC charts or S57 charts. So if you take a look at this, I have my data right here in a compressed format, but Global Mapper, we can load these right into the workspace, drag and drop a zip file, and I'm immediately prompted to load these all in one layer or in multiple group layers. So I want to click yes, because I'll want to manipulate the data depending on what I see and what I want in the legend. So here you see all these little texts with the
I think you have all of your labels turned on, Bill. If you go to configuration and go to your labeling, you can probably declutter your text here a little bit. So
yeah. Let's declutter this a little bit.
There we go. You do not want to display all labels.
That's a little cleaner. Thanks, David, for the tip and trick. Okay, so from here you see I have a vector format with all the pre-configured styles for the S57 navigational charts. You see in the the control center on the left side, I have a directory tree that I can open up, and I can see all the multiple layers that have been split out of the one file. So if I unclick a few of these, they'll start disappearing from the workspace. So if you want to as well, you can just show these in a legend to see what you have in the workspace as well. So quickest way to do this would be going to the configuration and going to display options, map legend. Just to show you guys how this looks like if you were to not set this up in a way that looks visually pleasing. If I click OK, I should probably check my option to display the map legend on loaded vector types. Sorry about that. So I'll click OK. And you see on the right side, we have all the possible feature types or feature descriptions listed on the right side. So if you want to clean this up a little bit to make this more visually pleasing, I can set this up to have 2 columns display. I can click apply, and the changes will immediately take effect. Another way to also clean this up as well, if you don't want all of the features listed in the legend here, you can uncheck some of these layers in the control center. So if you don't want base display group, maybe you're not interested in seabed instructions and pipelines, these begin to take effect in the legend. They start to go away. So if you turn these back on, they reappear. And there's also a way to do this as well back in the labels map legend tab in the configuration option. So you can filter the specific layers out here. So if I were to clear all and just keep a couple, see they show up right in the bottom corner of the workspace. So I'll go back to 2 and check these back all on. So just a quick little demo of how to show the different types of features in the ENC navigational chart with the layers. So
yeah, and the fact that these are vector features, they're queryable, they're editable, and Billy, might be worthwhile even taking a look. You can add a symbol here. You know, obviously you want to be careful before you do this, but these are point features. The buoys, etc., are point features. You can add them. You can create your own or supplement this data or modify the data in any way. So Billy, maybe just quick take a look, just drop a point. Obviously this is not done with any relevance or accuracy, but the symbology that's being applied to these automatically can be done manually as well. So if you specify that style, Billy, and use that drop down all the way at the bottom, those of you familiar with this format, you'll see the S52 symbology right here. This is obviously something that's universal and recognizable, so you can create your own bathymetric charts using this tool. So, two different variations of importing files into Global Mapper, one raster, the BSB charts, and a little bit of processing Billy showed us, and obviously the vector version as well. So I'm going to grab this screen back again, Billy, and we'll be back with you in just a minute, just a few minutes. But before that, I'm going to take a look once again at the general bathymetric chart of the ocean. We actually had a comment come in that somebody worked on this project. We're glad this is relevant. Long time ago, somebody mentioned they actually worked on this. This is, again, it's an ongoing effort, as mentioned before. This is generating this global bathymetric model. It is ironic, by the way. I was reading an article last night that I guess the latest Mars rover is going to be landing on Mars within a few days, or I'm not sure if it's imminent. But it's well known and it's well cited that we know more now about the surface of Mars than we do about the surface of our own planet. So this effort that's being pushed to generate this map of our ocean floors is actually filling in something. We're kind of missing out the perspective of our own planet, essentially. Most of our planet obviously is a marine environment, and we don't know very much about it yet. So hopefully this effort will continue, and there are some remarkable landforms that are hopefully going to be exposed to our mapping efforts. So, okay, so when I left you, I had taken a look at this website and simulated the process of grabbing some data, noting some of the formats I have access to. I've actually done this already, a little bit like a cooking show. I downloaded some data. It did not take long. And I'm going to drag that data into Global Mapper, and we'll take a look and we'll play with some of this the gridded version of that data. So from off screen here, just drag and drop. And any of you who have worked with terrain data in Global Mapper will immediately recognize that what we've done here is apply a shader to the data. This is a kind of a merged data set with terrestrial topographic data as well as bathymetry. And as you can see, the shader at the top of the screen here is representing my elevations. You'll see significantly the cutoff here at 0. Everything that's in the yellows and greens and blues represents our bathymetric data. I'm going to address the shader in just a few minutes. But for those who have never used Global Mapper, maybe you came along because you're working with bathymetry, bathymetric data, but you haven't seen Global Mapper, it's worthwhile taking a few minutes just to explore some of these 3D tools that we have access to now. First, and probably the most important, is the 3D viewer. So if I pop this data up in a 3D view from a 3D perspective, you'll see by default it gives me an oblique perspective. And I'm not sure how smooth this is coming across on the streamed version of my screen, but as you can see, I can alter my perspective, alter my line of sight, if you like, from my oblique perspective, and you can start to see some of these landforms quite clearly, the edge of the continental shelf coming into view here. The 3D viewer gives you a few different visualization options, a couple here, one referred to as fly mode. The other, probably my favorite, is walk mode. Walk mode allows you to basically place yourself on the surface and walk across the terrain, whether that be terrestrial or whether that be bathymetric. So you can see I'm kind of walking around here, hopefully getting into the ocean a little bit here, and you'll start to see, I think we'll eventually drop off there. We're going down off the continental shelf. I'm not sure, again, if this is coming across in a clean form.
It looks really good, David, actually.
Good to hear. Good to hear. There, we're doing some subsea exploration here from a first-person perspective, as you can see. Now, again, this is fairly low-resolution data with the higher resolution data. We'll take a look at a few minutes at some higher resolution data. You can do some interesting visual interaction with that data, again, from a first-person perspective. Another interesting tool, useful tool, is a profiling tool, and we'll look at a few variations on this tool. From my toolbar, I'm just going to grab the Path Profile tool, and I'll create a simple cross-sectional view again, targeting the edge of the continental divide here. You can see it quite clearly. It's a drastic drop-off from almost, looks like a few meters, right down to 3,000 meters below sea level here. So another way of visualizing your 3D data. Now, I mentioned before the idea of visualizing data based on a shader. Because this is gridded data, unlike this snapshot we saw when we looked, for instance, at the Puerto Rico Trench before, where the colors were pre-assigned, with this data, you have the flexibility to assign whatever colors you want. And there are a number of pre-configured shaders that are available. A gradient shader, for instance, will give you just 2 colors from, in this case, white to black with an interpolation of the actual colors applied. We have, what else do we have? We have a global shader, which gives us a different perspective. This is an interesting one when used with bathymetric data, because you can see, again, a clear distinction between our terrestrial areas and our bathymetric areas. But what I find to be most useful for this is actually to build my own. And I'm going to create a custom shader very quickly here, specifically for use with bathymetric data. Now, those of you who have never seen this before, very simple. You simply assign a particular color to represent a defined elevation. I'm going to begin with 0, because my 0 elevation, I want to make that white. I'm going to add a few others. Anything that's above 0, I'm going to put 1 in here as my only positive value. I'm going to make this like a beige color or something a little more subtle. This is going to be my terrestrial areas. I'm not interested in any visual distinction between those. So this will be the single color that will be applied to everything above 0. Then I'll get into the bathymetric data. I'm going to begin with -200. And again, assign a color. I want to choose kind of a mid-range blue for this. And finally, for the deep areas, one further value here, -4000. And we will make that a deeper blue. Now, one of the critical settings here, I'm obviously going through this rather quickly. One of the critical settings is that we're going to blend colors between these values. So because I'm blending, everything that's above 1 will be essentially a uniform color. We'll have a little blending between 1 and 0, which are coastal areas, and then between 0 and 200 below sea level and 204,000 below sea level, we'll get blending between these colors. Now let's go ahead and click this and take a look, and you can see again, it's much more apparent now, just simply based on a change of the shader, what some of these submarine landforms look like. A very clear channel going out from the Gulf of Maine. I believe this is the Georges Bank, which wasn't initially available with our default shader, but now comes into play. And the reason for this, again, is because we've applied an interpolation based on defining these values. Now, this shader tool, you can customize to represent the data in whatever way you want, giving you a kind of a more useful perspective. Final thing I want to show you with this data specifically is the generation of contours. As I mentioned in the introduction, contours were first applied for bathymetry before they were applied for terrestrial topography. So it's very appropriate that we're taking a look at this tool as well. I want to generate some bathymetric contours using the button in my toolbar, Create Contours. We define a contour interval. I want to make my contours 50 meters apart. And I'm going to limit the contours to the bathymetric area. In other words, I don't want anything above 0. 0 is going to be my final cutoff here. There's a few other options in here to find local peaks and depressions. I'm actually going to do that in a different workflow in a few minutes, but for now, we'll not apply that. I think this should be fine. We click OK. And within a few seconds, hopefully if my screen catches up with me, we should see our bathymetric contours generated here. And again, probably most interesting when we get to the edge of the continental shelf here, you can see them dropping away. Also interesting are these seamounts. I was doing a little visual analysis before I came on the presentation. You can see quite distinct mountains here off the edge of the continental divide. Those familiar with kind of the nearshore bathymetry of North America will obviously be familiar with some of these landforms, but I find it fascinating now to be able to see these. And again, using some of the tools that we would typically apply to terrestrial topography. These are striking mountains. These are very spectacular features that we're seeing right here on the ocean floor. Okay, so this is obviously visualization of bathymetric data using some pre-existing data. And again, I pointed to that source where you can download these grid files. I happen to download an ASC file, an ASCII grid file. So supported by Global Mapper, you can absolutely bring that into Global Mapper and conduct this visual analysis. We're going to bring this down to a more localized context now. We're actually going to bring in some sonar data or some hydrographic data. And Billy, I'm going to pass the screen back over to you, and maybe you could walk us through that process where we can derive a surface from some of that marine survey data.
Okay, great. So hopefully you're seeing my screen just outside, just southeast of South Portland here. And as David mentioned, I will be showing you how to load some sonar data that was actually collected from the website that he showed earlier here. So I zoomed in off the coast of Maine here. You can see the polygons of the outlines of where these scans have been done. So we'll be working with this data set here that's identified. There's different polygons that I actually have selected over. So I'll be using the one that is 1998 in this data set. So I'll minimize this. My data here is a .xyz file, which I can drag and drop again into the workspace. Since this is a text file, the generic ASCII text file format options window appears with the various settings here. And with this new file preview, it makes things a lot easier to load this data in. So I want to make sure I choose to pick a LiDAR point cloud. It's much more efficient to process this file if it's this and not a point cloud, or point only, like a point feature. And I have my coordinate format here correctly. It should be longitude first. I got that correct. And I want to skip the first field here. This is just the survey ID here, so this doesn't really have any reference to the geographic location of the file. I don't want to skip the first row of the file, but I'm going to include it as a header. So the first row of the file is the header. So, and I'm going to uncheck include attributes from the lines with coordinate data. And the third column, or fourth column here, is actually the depth data. So I'm going to check that as the elevation value and just click OK. And use the projection file. It's in the workspace already. So as someone mentioned earlier, they were asking about how do I, if I have positive elevation values, can I change those to negative or vice versa? And since the data values aren't negative in the text file, you can see that these are positive values. I want to invert these or make them negative. And if you remember from grade school, you just simply multiply each value by -1. So I right click on the file in the control center and go to options. I can go to the alter elevation values tab. And I simply just want to use a scale factor of -1 and click OK. You should see the values flip to negative values. And you see the numbers have reversed on my shader here. And actually can open this up in 3D, show you. So now these blue areas are now lower, and the areas that are red, which are closer to the surface, are higher. So more realistic visualization of the data, of the bathymetry data.
Yeah, and we did have a couple of questions on that theme about positive data. I mean, obviously Global Mapper looks at the actual Z value itself, and depth is typically considered a positive value, but if you deal with that in a raw sense, the assumption here would be that the areas that are deeper would actually be higher above sea level. So you do need to, if you're using this type of data, you do need to invert it that way.
Yeah.
And that's what Billy did. Also, Billy made the decision there when he imported to use the LiDAR format. Well, kind of getting into the world of point cloud management here. Now, this is obviously not LiDAR. This data was collected, I think, even before LiDAR was invented. But structurally, it has the same characteristics now. And Global Mapper is optimized for processing LiDAR data very efficiently. I did an experiment with this very small sample, I think 100 and something thousand points, 168,000 points.
Yep.
In LiDAR, in the context of LiDAR, very small. And you can see when Billy navigates around, the response is virtually instant. With 168,000 individual vector points, there is a noticeable lag in terms of the response, just simply because you're dealing with data of a different format. So the recommendation, if you're using any type of XYZ data, importing it into Global Mapper as a LiDAR file. Again, you have to use the term loosely. It is not technically LiDAR, but pretending it's LiDAR gives you the optimal performance within the application. Somebody asked, it's an XYZ file, how is it interpolated? Basically interpolated between the Z values. We have measured elevations at those sounding points. Between those, it's an interpolated model, obviously. So we're making some assumptions between those areas. Billy, if you wouldn't mind doing me a favor again, bringing up the gridding dialog box, because there is one setting here that's applicable. Right at the bottom, you'll see a no distance criteria slider. Now, I don't want to get too into the technical details here, but this allows you to determine that interpolation. If there's areas where there is no data, keeping that slider towards tight will respect that fact and leave areas that are basically with no points, it will leave them null. There'll be no terrain or no bathymetry. Moving it towards the loose will essentially fill in those gaps, will apply that interpolation. So it's really a decision you need to make as to whether holes in your data should be retained or whether you want to apply that interpolation. But again, a couple of questions specifically on this idea of interpolation.
And now, being in this window now, so now that I did import this as LiDAR, I can create an elevation grid of the sounding data itself. So I'll have a nice hard surface. So if I use a recommended 25 here for this data set, just click OK. Now I have a hard surface of the underwater surface here, which I can also visualize in 3D. This probably will look a little better than looking at the point cloud itself or the sounding data. And now with this, you can really start to analyze doing terrain analysis, as Dave will touch on, looking at shipping lanes and dredging, as well as applying, taking a look at cable routes, which I will show in a couple of moments here. So, excellent. Yep, so back to you with actually looking at.
Sure, I'm going to grab the screen again. I actually have the same data that Billy loaded, so hopefully you're seeing that as well. Slightly different variations on the shader here. And again, I created a custom shader for the last scenario. And by all means, if you want a shader that's more appropriate for a project you're working on, by all means, you can do that. I'm going to turn off a couple of the underlying layers here. We had a topo map in there just for visual context. We know this is kind of a nearshore area. I've simulated a shipping channel because what I want to show you in a few minutes is kind of the process of modifying the surface or modifying the bathymetry. Maybe you need to do some dredging, and we're going to simulate that process in just a second. Now, again, addressing some of the specific questions that are coming in, and there's a lot. Someone mentioned about the generation of soundings, specific soundings. You can create point features on top of any surface in Global Mapper. Now, they can be done either manually, or you can create random points. There's a tool using our digitizer to assign random points distributed throughout the area, and you can derive the elevation from the underlying terrain, or in this case, bathymetric model. So if you need spot soundings randomly distributed, there is definitely a way of doing that, or indeed regular points as well. You can generate a regular array of points and apply the elevations to those. Billy, I think you're going to do something similar with a line a little bit later, so maybe we could revisit that topic.
Yep.
Also specific to areas of particular interest, one of the tools I mentioned in the contouring scenario, I'm going to take a look at again in the context of this more localized data. I'm going to bring up my contouring tool once more, and in truth, I'm not really that concerned about the contour interval itself, just noting my scale here, we're between 7 and 55 meters below sea level. We'll generate 2-meter contours. That should be sufficient for what we want to do. But specifically what I'm interested in this example is looking for local peaks and depressions. This will identify, based on a number of concentric contours that I define here, where those local areas, those seamounts, or those local depressions are within our model. Let me go ahead and bring this down a little bit, so we're discarding just our shorter contours. Under 20 meters, we'll discard those. So with these settings applied, we'll click OK. And now you can see where those seamounts are located, those localized areas that are higher than the surrounding ocean floor, identified with these little triangles. This layer that I've created, obviously we've got contour lines, but we've also got point symbols. It isn't a single layer. I'm going to show you a little trick here. I can right click and I can break this into kind of more manageable chunks, if you like. Actually, let me try that one more time. let me split this. I'll go to the layer menu and we will split this into separate layers. I'm just going to base that on the feature description. I'm going to click OK. Now what has happened here is I have taken the lines and the points and separated them. So I'm going to turn off all of the lines. Now we have isolated these spot heights, indicating local high points within our area. This can be done obviously for terrestrial topography, terrain, or indeed for bathymetry. So it gives you a different way of deriving meaningful information from a surface model. Okay, so let's get back to this simulation. And again, with apologies, this is entirely hypothetical and used as an illustration of some of the tools in Global Mapper. We have here defined a ship channel. This actually is the approach to Portland Harbor. In the summertime, you'll see the cruise ships all coming in here. So that's going to happen this year, but very scenic area, right past some really nice lighthouses. So if you're ever in the area, it's certainly worth getting down to the shore and taking in some of the scenery. But for our situation here, what we want to do is to make sure that there's enough clearance for these vessels to come into the harbor. And again, this is hypothetical. This is going to be based on simulated data, so it's not a real scenario. There are a few ways that we can modify the surface. One of those we've introduced fairly recently. I'm going to show a quick example of that. Right from my toolbar, I'm going to enable a function called terrain painting. Now, terrain painting will literally allow me to draw some new terrain, and you can do that based on a number of these variables. We've demonstrated this before in the context of terrestrial analysis, but here we can use it for bathymetric analysis as well, where we can define a height, we can lower the terrain, etc., etc. So if I establish a specific height, as noted here, I choose that option. I choose the brush size. If I'm doing point, line, or polygon, I can choose the brush size, or I can define it based on drawing an area. I'm going to create a line, and it's going to be 10 times the grid spacing, in other words, whatever the resolution of the data is. And I can then define the height. So I'm going to go for a height of minus 22 meters in this case. That will ensure that my terrain, the resulting terrain, will be specifically that depth. And thereafter, it's simply a case of drawing. So if I move my cursor through the terrain, you'll basically see it looks like a drawing tool. I'll finish that process and you'll see at a local area here, I've literally drawn some terrain in here using that predefined value. So from a manual perspective, I could sculpt the terrain and derive a new surface model simply by using some of these drawing tools, and you can see some of the other options that are available here. For this example, I'm actually going to use a predefined polygon to determine my elevation. And for this, I'm going to select this line feature, this ship channel line. It's just a line drawn on the terrain. I'm going to buffer it. And the buffer I'm going to establish is going to be 100 meters wide. So my buffer zone will basically define a fixed distance width of 100 meters. A few other options for buffering here. You can taper the buffer if necessary, have multiple buffer zones if necessary, but not really relevant in my case. I'm just going to call the target layer buffer, and we'll click OK, and we should, as a result, see a polygon that was derived from the original ship channel. I'm going to turn off the line. I'm left with the polygon because now I can use that polygon to determine the precise elevation, my target elevation, or in my case, my target depth. And the way I do that is simply by defining the elevation associated with that feature. This is just a simple polygon right now. I'm going to add a new attribute. Just simply call it depth. You can call it height or elevation. It doesn't matter. Something that implies that it's a Z value. And I will give it, once again, a defined depth, minus 22 meters in my case. And we'll click OK. Now, that's all I need to do, because going back to the original point cloud, if I repeat what Billy did, and let me turn off the DTM, I'll turn on the point cloud once again. We're back to where we started, but now I have defined the elevation of that channel, because if I repeat the steps that Billy went through, I have the option to incorporate the polygon that defines my ship channel. with that embedded elevation. This process is called hydroflattening, and it's available with the LiDAR module, where not only are we defining the gridding process using the point features, but also using either 3D area or line features. So in my case, my 3D area feature, my polygon, is going to override the elevation in my points to create a flattened surface of a specific elevation. And I can create a soft edge. Basically, this will give me a tapered edge defining the slopes along the edge of my buffer. So with these settings applied, we'll click OK. And we should, as a result, see a nicely dredged channel. I'll turn off my buffer. That's served its purpose. And you can see now, obviously I haven't done the whole extent, but you can see I've created this simulated subsurface based on a dredging operation. I can use the profile tool I introduced quickly earlier, create a cross-sectional view, and you can see what I have dredged. Now I'm going to do a little bit of comparison here before and after. We can do this from a couple of perspectives, from a visual perspective, but we can also determine how much material needs to be dredged for us to create this channel. And we'll take a look at a couple of examples, or kind of that scenario. The other thing I want to do here is some kind of visual comparison as well. Now, I have the original DTM. If I use my image swipe tool, which is a tool available in my toolbar, I can pull back the newer surface and I can see the one that I have modified. I basically have two variations on this theme. I can also I can also create a profile of these two views, which is quite interesting. I'm going to use my original ship line as the basis for my profile. So simply right-click, Analysis, Measurement, and Path Profile will give me a cross-sectional view showing me the modified surface, which we know is exactly 22 meters, and then what the original surface looks like. So along the course of that kind of ship channel, you can now see the amount of material that would have to be moved. To make this even more meaningful, I'm going to change this perspective to create what are called perpendicular profiles. So I want to create cross-sectional profiles along my ship channel using the same tool I showed before. This time, I'm going to go to my settings first and display my perpendicular profiles with a distance between each of 10 meters, and each width, we'll make it, let's make it 200 meters wide. So you'll see the results of this setting in just a second. When I generate my profile view now, let me just go ahead and grab my line once again, right click. We'll go to Analysis, Measurement, Path Profile as we did before. I need to reestablish those settings with apologies. We'll do that one more time now that we have an active profile. You'll see the results of this in just 1 second. Once again, my length, 200 meters. What you'll see in my profile view is if I drag down this window and dock it, you'll see a series of cross-sectional views, noting where the original surface was and what has been modified. Now, probably would need to widen that a little bit to give us a full perspective. Let me actually go ahead and do that. Just widen it, maybe go to 300 meters so we get to the original surface a little more clearly. There we go. So we can now see that modified surface displayed as we transition through each of these sequential views. The original surface is my blue line, the modified surface obviously noted in the profile, the green profile view. So you can transition down this channel and see this, how this modification process has been applied. Now, final thing I want to show with this is the ability to capture this data as vector features. We can save each of these cross-sectional views as new lines. And again, I'll quickly do this. I'm going to close my profile view, turn off a number of my layers here. As you can see, I'm accumulating a lot of different layers in my control center, and we're left with a series of lines. I'm going to turn off the labels for these. These individual lines represent the cross-sectional view of my modified surface. If I pop this up in 3D, you can see this quite clearly this way. I didn't go wide enough with these. I should have gone a little wider. But you can see this ship channel now represented as a series of line features as opposed to just simply in the surface. And these, again, vector lines, 3D vector lines can be exported if necessary, imported into another application. Okay, one more thing I want to do here. I'm going to bring up the original surface and the modified surface that we created. So what Billy did originally, again, both layers are now on my screen, because what we need to do next is calculate how much material is going to be dredged in this scenario. Just to confirm once again, I have the original surface and I have the modified surface. I'm pulling back one layer to see what's underneath. This process is a simple calculation. Because we have two surfaces present, we simply go to analysis and we measure the volume between these two surfaces. Simple little calculation. You can choose your volume units, what to subtract from, what to subtract to, etc. I'll simply click OK, and we get a report telling us exactly how much material is going to need to be cut in this area. And it looks like it's a little over 1.2 million cubic meters for this short section of my my channel that I've generated here. For visual comparison, we can also show a difference model where we take the original model and we subtract, or we take the modified surface and we subtract the original. So I'm going to take the original, again, do a subtraction. I'm not worried about whether it's signed or unsigned because we know we're dredging, so we'll make it unsigned. And this will generate a third surface model that represents the difference between the two. I'm not going to change the name of the target layer. It will generate it, and you'll see now we have a visual indication of where that dredging process will take place. Obviously, again, reflecting the colors. This is how much material will need to be dredged, noted on the elevation legend on the left side of my screen. So a few different variations on the theme of creating a modified surface and then analyzing the difference between the original and that modified. And you can see, by the way, the original simulation I conducted with my terrain painting tool is also noted up here in my surface model. Okay, so we're quickly running out of time here. We're going to take a quick look at one other scenario here, and I believe, Billy, you're going to be using the same data to do some subsurface measurement, three-dimensional measurement, again, maybe seafloor simulation or seafloor cable installation simulation.
Yep, so after David's scenario, if you're possibly looking at now installing cable lines under the ocean, and you want to see, the actual measurement, not just the 2D measurement, but the actual 3D measurement of perhaps a cable that lies right on the sea surface. So to start this, I can quickly just digitize a line feature along the area of my interest. So I'll say right through here in the shortest distance. And I'll just put this in the user created features layer. So I'm just dealing with one. So now what I want to do is apply the elevation of the sea surface to the line feature itself. Currently, there's no elevation associated with this, but I can use the underlying terrain to add the elevation. So I'll just click with the digitizer, and then I'm using the right-click digitizer menu and going to Analysis Measurement and click Apply Elevations to Selected Features. And the only option here is to use the terrain layer, so I click OK. And the prompt tells me that it's been updated. I can also see that, actually, I think I may have skipped a step, but what I want to do is actually resample the line each meter and apply the elevations to each vertex I applied along this this line feature. So
yeah, that if you do that by resampling, basically the elevations that are applied, and this goes back to a couple of questions that came in earlier, in terms of defining sounding locations. Any point feature or any vertex in any line or polygon can be assigned with the underlying terrain, in this case, underlying bathymetric values. But to make this meaningful in Billy's example, I'm just going to kind of talk you through this. Billy's going to resample this so that there are more closely spaced vertices. I would say every meter, Billy, in this case. So he's basically resampling the line so that there are shape points, if you like. You can see that visually on the screen now, where each of these shape points are a meter apart. And the elevation of the underlying surface now will be applied to each of these vertices.
Yep, so there we go. Now we have the elevations applied to each vertex. So if you want to visualize this in 3D, I can open the 3D viewer. Maybe I should unselect my line here. You can see it on the terrain surface. But if I uncheck the DTM right here, I should be able to see the cable line with its varying degrees of height changes here. So you can kind of visualize where along the seabed this line would be, or this cable route would be. And if I go ahead, I can also take a look at the 3D length by also selecting the line feature and right-clicking and going to Analysis Measurement and going to Measure Feature Display Measurements. You can see the length is pretty much the same. It's just the 3D length that was added to this feature measurement.
Actually, Billy, if you close that, you're going to update the attributes of that line. So if you right-click after selecting it and go to Attribute Style and you update those measure attributes, what you're going to get if you use the Info tool, you're going to actually get the 3-dimensional line. It's not going to be that much difference in this local context. You're going to get the original 2D length and the 3D length displayed here as attributes for that line. So again, in this example, if you are laying a subfloor or a seafloor cable or something, you get a more precise measurement of the 3-dimensional line rather than just simply drawing a 2-dimensional line across the seafloor. Which I think brings us to the end of our session today. There's so much more we could talk about. Those of you who have not used Global Mapper, obviously, we give you a little bit of a snapshot. Some of you were asking more specific questions about some of our workflows. Obviously, to get through what we needed to, we went through some of those scenarios a little bit more quickly than we would typically do. Feel free to obviously to look at the recording of this if you want some more detail, or indeed if you're interested in these tools and maybe using them yourself. Maybe training is a good option for you. Again, I mentioned at the start, we have some training coming up. We'll certainly be covering in much more detail a lot of the functionality that we covered today. So. Which again brings us to the end of our session today. Billy, I appreciate you taking the time from your busy schedule to join me today.
Yep, no, hopefully the users can forgive my little snafu at the end there. But
No, snafus happen all the time. If you have questions about Global Mapper, a couple of different emails here. If you have questions about licensing or the purchasing process, orders@bluemarblego.com is your best bet. If you have questions about any of the content we had today, and we had a lot of questions, with apologies, we weren't able to answer all of your questions, but those questions that were asked, we will follow up with. If you have additional questions, or indeed if you're watching the recording of this presentation and you have questions about any of this content, please send an email to geohelp@bluemarblego.com and we will get back to you with the response. Or if you're new to Global Mapper, go to bluemarblego.com and you can download the software as you saw it today. In fact, if you wait till tomorrow, you'll get the latest version 22.1, and you can request a trial. You've got a 2-week trial that will allow you to put it through its paces. Folks, thank you for joining us today, and thank you for all your questions, and we will see you next time when we introduce Global Mapper version 22.1. Thank you.